Hello there. So today I thought I'm going to make a video on Google Gemini 2.5 Pro's abilities to generate wind loads automatically on slightly more complex structures. And this is following on the video that we made yesterday about Grok 4 versus OpenAI versus Gemini's abilities to maintain spatial awareness and generate 3D models, structural models within GenFEA. I was so impressed with Gemini, I thought, let's take it a bit further. Let's create a more complex model and see if Gemini can perform the task of calculating and applying the wind load. So you can see the settings I've set up there in DesignMate, the AI companion in GenFEA. We're going to use the input workbook creator. We will prime the model. So that's going to get GenFEA to feed the model input data into the prompt. And then we've built a new tool to take a screenshot. So we're also using the vision functionality within these LLMs to actually see the model and also understand the model and how it's built by feeding in the input workbook. So we feed that through and we can see fairly quickly in about 17 seconds, Gemini responds and it says, okay, it understands the model, it understands the composition, the design, groups that's been set up, the load cases, the connectivity of elements, materials, location of the model, etc. Then we'll use the wind load generator applet, which obviously, as you might know, are tools that you can customize and set up yourself. So I built one for wind loads, and I'm just telling it apply wind loading in the X direction. I've sped up the video obviously quite a bit, as you can see there, but it took less than a minute to run through, or pretty much a minute. And once it's done, we can see, it's starting to generate output. And immediately we can see that it's recognizing, based on the project location, the correct wind loading code to use. And we can start seeing that it's calculating some design parameters using the wind region and annual probability of exceedance, etc., etc. And from the input workbook, we can just verify and see that, we've got a map locator there and we've already specified the location on the map, so it knows where this project is located. So we'll just wait for this to run through. It's busy generating that wind load input table for GenFEA, and once it's done, we should be able to bring that in. So, okay, we've now got the complete table, and we can see the wind region there has been picked up, the annual probability of exceedance, 1 in 500 years, the regional wind speed. We've got the terrain category picked up there. The average structure height is 4 meters, which is correct. The multipliers there, it's determined. So the wind direction, terrain height multiplier, and the topographic shielding multipliers all being determined automatically. So the design wind pressure calculations are over there. So we've got 38.9 meters per second, and the design wind pressure converted into our units, which is Newton per millimeter squared. And we can see those additional calculations there on the columns, the suction and the purlins uplift, which is what we've asked it to do. Now, in hindsight, I could have probably I could have split my model up better and created more design groups for my side rails, roof purlins, for the different stepped roofs, etc. I didn't. I just put all of my purlins on the same design group. But this is going to show you how quickly and how amazingly Gemini can actually maintain spatial awareness, understand the model from the spreadsheet input data, as well as the vision model capabilities in that snapshot that we generated. And if we switch on the wind load case here in the model and we display the loads, we can actually see the loads there being applied for the wind load. So we can see on those external columns there, more or less half of what they are in the internal columns. We can see uplift applied to all of those purlins. Again, I probably should have split my roof purlins and side rails into different design groups. And instead of saying apply uplift on all the purlins, I should have been clear and said roof purlins only. But it's applied them correctly. Nothing here is out of place. All the loads apply to the elements that we've asked for, and all the reasoning are present in the output from the LLM. This is absolutely fantastic. So it's generated like in excess of 300 loads in the model, and it's calculated those correctly based on the prompting that we've provided in a minute flat. That's just fantastic. So, okay, let's see what this model would actually look like if we start calculating and running the analysis. So to do that, I'll just set up a couple of load combinations. just as a simple test to see, if we get some realistic outputs here. So we'll set up two load combinations, and then we'll run the analysis. And at this point, I realized I forgot to supply supports in the model. So we'll just quickly add fixed supports at all the nodes where the level is 0. We'll run this again, and then we'll see what that looks like. So switching on the deflection for the dead load case, that's what it looks like. For the wind load case, that's what it looks like. Maybe we'll switch on a combination case. So this is our combination 1 with dead load and live load only. And if we switch to the combination 2, which is dead, live, and wind, this is what it looks like. Okay, so at this point, I realized that I probably forgot to specify the end releases on my purlins. So I quickly went back, set that for the entire group to make them torsion pinned, and then run the analysis again. I sped this up a little bit, but it's reasonably quick. We'll go back to that combination case again. We'll isolate the purlin output and just look at those moments and see we don't have any transfer of moments between those purlin elements, which looks good. And then just for a bit of fun, let's switch on the deflection again, display all the design groups, and we can simulate or animate that exaggeration of the deflection to see, how this building performs as a mechanism with those applied loads for the wind loading. So pretty cool. I mean, this is not the most complex model ever, but it is reasonably large in terms of the amount of members and connectivity and how things fit together. So I'm quite impressed with Google Gemini. I hope you enjoyed that. Cheers. Bye.